Well, this should be interesting. It looks like another day of using trigonometric ratios. And we've got some dinosaurs again on this opening slide. Let's see if we can get these dinosaurs moved along. Oh, this time Barney's being chased away. Okay, come on. All right, so another one. Come on, keep moving out of the way. Let's focus on this learning target. Students will be able to use trigonometric ratios. And again, that just means the answer is going to be a fraction, right? A trig ratio is a fraction. SOHCAHTOA is my memory device, right? Sine of angle theta is the opposite side over the hypotenuse. Cosine of angle theta is the adjacent side over the hypotenuse. Tangent of angle theta is the opposite side over the adjacent side. So you're like, hey, this looks just like the previous lesson, piece of cake. Well, let's see if it stays to be a piece of cake. Okay, so find each ratio. Sine of A. Well, 6 over 10, right? Opposite over hypotenuse. Ooh, this reduces, right? 3/5. Cosine of angle A. Well, 8 over 10. That reduces. Tangent of angle A. 6 over 8. Again, that reduces. Okay, so this looks like it's going the same as yesterday. Find each trig ratio. Okay, so same deal. So we need sine of angle theta. So, opposite theta is square root of 7. But what's the hypotenuse? I have to know the hypotenuse to answer the question. Hey, there's a right angle. We know what we can use. The Pythagorean theorem, a squared plus b squared equals c squared. Right? If I know two sides of a right triangle, I actually know all three sides of a right triangle. Okay, and so root 7 is one of the legs. 3 is one of the legs. Root 7 times root 7 is 7. 3 times 3 is 9. 7 plus 9 is 16. Got to take the square root. Square root of 16 is 4. Hypotenuse is 4. Yep, get over there, 4. So sine of theta will be root 7 over 4. Cosine of theta will be 3 over 4. Tangent of angle theta, root 7 over 3. Right, so sometimes we're missing one of the sides of the triangle, and we have to use the Pythagorean theorem. Here we go again. Once again, we're missing one side. Sine of theta. Oh, we can do that. Opposite is 21. Hypotenuse is 29. Piece of cake. Cosine of theta. Oh, I don't know the adjacent side. A squared plus b squared equals c squared. C has to be 29, right? The hypotenuse is 29. For the 21, though, I could pick A or B, right? Does not matter. Mix and match with the Pythagorean theorem if the angles are not labeled. As far as the legs go for A and B, right? Probably calculator time for most of us. Now remember, if I'm looking for a leg, I actually end up subtracting. So don't go all hyper with your calculator and think a squared plus b squared. I must add. No, 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 no. We're looking for a leg. We subtract. And square root of 400. Well, 2 times 2 is 4. So 20 times 20 is 400. Now we know our missing side. Yeah, get over there. So cosine will be 20 over 29. And tangent will be 21 over 20. And there we have it. Ooh, worksheets. Ooh, a flying saucer. Some other spacecraft. Ooh, worksheet is rearranging. Another flying saucer. The Millennium Falcon. I wonder what it's going to spell so those letters rearrange. Hey, space shuttle. Ooh, here comes another flying saucer. And it looks like the letters from worksheet get rearranged to say worksheet. Well, that's a little bit anticlimactic, but that's a nice flying saucer there, though. Right. And finally, another flying saucer.